Video we're going to look at another example of relative acceleration in pulleys, and this is from the Pulleys book, worked example 5.13. So it is on page 87 of your textbook, but there is actually a mistake in it. So this shouldn't read m here, this should actually read 3m. So just when you're looking at the solutions in your textbook, you'll see that they're a little bit different from the picture. So the only difference between this question and the last question is that we don't actually have numbers, we have the mass in terms of m. If we look at the question, we have a 5m particle A, which is connected by a string over a pulley to another particle C. Now it says over pulley C, it calls pulley C a light movable pulley. Now if it says those words light, it means that the mass of C, I'm going to write mc here, equals 0. It doesn't weigh anything. In reality that couldn't be the case, but in these questions we can make that assumption if it's really light compared to the other particles. In pulley C then we have another string which is connected to particle D, which has a mass m, connected to particle E, which has a mass 3m. And the question is, find the common acceleration A of A and C, and also find the common acceleration B of D and E relative to C. So if we look at what's going on, remember we kind of split this into one big giant particle. And because A has a mass of 5m, and the total mass of this would be m plus 3m is 4m, we'd assume that A is going to go down and this block is going to go up. Now that's the acceleration of A and C, so we can call that acceleration A. While this is all going on though, there's going to be some movement in pulley C, or in the particles kind of connected by pulley C. We have a 3m mass E, which is obviously heavier than the mass D, so we assume the 3m will go down with an acceleration B, and the m will come up with an acceleration B. So they've described this acceleration B as the acceleration of D and E relative to C, and that relative to C means that if C isn't moving, B is accelerating down at this rate. But remember, that isn't the overall acceleration of E. The overall acceleration of E is going to be some combination of the B and the A. So it's going to be either B minus A if B is bigger than A, or A minus B if A is bigger than B. And the overall acceleration of D, that's an easier one because D is going up and A is going up. That's going to be A plus B. A plus B. So we'll figure out whether this is B minus A or A minus B in a minute. So with all the questions, the first thing you always do is you do your particle diagram. So we'll do these, and hopefully you're well used to this now. So for the 5m particle, force pulling it down is 5m, force pulling it up is T. Then we do our F equals ma equation. We assume, because overall that this particle is moving down, the downwards force is bigger than the upwards force, so our F, or our resultant force, is going to be 5m minus T, and that's equal to its mass, 5m times A. That's equation 1. Looking at the light pulley C, it's being pulled up by the same string that's attached to A, so that has a tension T, and then there's a separate string pulling it down in two places, and because that's a separate string, it has a separate force, so we call that S. So when we do our F equals ma for this, it's moving up, so T is bigger than 2S, but it has a mass of 0, and because it has a mass of 0, it's going to be 0 times A, so its overall acceleration is 0. So we can rearrange this to say, well, T is equal to 2S, and that's equation 2. A little bit to the side there, ignore the baby crying in the background. We have particle M, or particle D, which has a mass mg going down, and it's being pulled up with a force S. When we look at particle D, overall it's moving up. So we can say that S is bigger than mg, so it's S minus mg, and this is our F equals ma equation there. So that's going to be equal to its mass, which is m, and its total acceleration, and this is a tricky bit, is going to be a plus b. And remember that a plus b is there because it's not only moving up with an acceleration b, it's also moving up with an acceleration a. So its total acceleration is both of them together. You can simplify that equation then to give you s minus mg equals ma plus mb. And we put a box around that, that's equation 3. Next one is our particle E. Now particle E has a mass of 3m, so its weight is 3mg, and it's being pulled up with a force S. Now when we look at particle E, and we'll go back to our picture here for a minute, we have two options really. Overall, is it actually moving down, or overall is it moving up? And what you need to do here is you actually need to just make an assumption. So we're going to make the assumption that it's moving down overall. And if we make that assumption, we're saying that B is greater than A. So that means its overall acceleration would be B minus A. You could do it the other way, but you're just making the assumption. If it's moving down then as well, we're saying that 3mg is bigger than S. So our force would be 3mg minus S equals its mass 3m times its acceleration, which was b minus a. So we write that out then, and we simplify that out then. We have 3mg minus s equals 3mb minus 3ma, and that's equation 4. Now remember, the question was to find a and b. Find a, find b. So what we need to do now is we need to use our 4 equations, and we need to somehow cancel things out or substitute or solve them in whatever way we can to find a and b. So what I'll do is I'll write down the 4 equations down here again. So our first equation was, what was our first equation again? It was 5mg minus t equals 5ma. Our second equation was t minus 2s equals 0, and we can put a 0 here. There's no mg term, there's no ma term. Our next equation was s minus mg, there's no t term, equals ma plus mb, and you see how I'm writing them all underneath, or each variable underneath its kind of corresponding variable. And our next equation was 3mg minus s, so that's a plus 3mg, no t term, equals 3mb minus 3ma. That's a plus. And where there's nothing, we can just write in plus 0 if we want to. And now we have all our equations, equation 1, 2, 3, 4. Now I've kind of written this nice and big, so it means I'm going to have to actually go down a bit when I'm doing the next stage. So make sure you pause it and take these down if you need to. So now we want to cancel things out so that we get a and b. Now we have 2 variables a and b, so what we're probably going to have to do is get 2 equations with just a and b. Now when I say just a and b, obviously we can leave in g because g is a constant, and we can probably leave in m because m is not given to us, so m might cancel down or it might not, but we might end up getting a or b in terms of m. So really what we need to get rid of is we need to get rid of the s and we need to get rid of the t from equations, somehow joining these equations together. Okay, so let's do it once, and there's a bit of thinking with this, so take your time with it, write all the equations out like this, and remember you can combine the equations in any way you want. So we can combine all 4, for example. If we combine equation 1 and 2, the t's will cancel. If we add equation 4, one of these s's, or equation 3, one of these s's will cancel. But if we add equation 4, the next s won't cancel, because if you look here we have a minus 2s, a plus s, and a minus s. So what I'm going to do is I'm going to multiply equation 4 by minus 1. This will now become a plus, this will now become a minus, this will become a plus, and this will become a minus. And now what I can do is I can literally add all the equations together. I can add equation 1 plus 2 plus 3 plus 4, which has been multiplied by minus 1. And we've 2s plus s will cancel. 5mg minus 1mg is 4mg, minus 3mg gives us mg. T's will cancel. Equals 5ma plus ma is 6ma, plus another ma is 9ma. And then we've minus 3mb plus mb is minus 2mb. And the m's do cancel first. And we're left with our first equation, which is 9a minus 2b equals g. Now that's one equation, but remember, let's call that equation A. Remember, if we have two variables, and we have two variables here, a and b, we need to have two equations, two simultaneous equations that we can solve. So we need to find another combination. Now I won't write all these out again, but I suggest you actually write them out again. But I'm just going to try and think through it here. We just want to get rid of another variable. So I'm just going to look at 3 and 4 here. And if we look at 3 and 4 in their original form, I'll write them out again for us underneath. Equation 3 was s minus mg equals ma plus mb. That was equation 3. And equation 4 was minus s plus 3mg equals 3mb minus 3ma. Was that correct? Is that what I had in the last one? Yeah. Minus s plus 3mg. Okay. So now the reason I've just picked these is because there's no t in them as it is. And we already have a plus s and a minus s. So when we add them together, they should cancel. We've 3mg minus mg is 2mg. And I'm going to do this quickly because if I go too much longer, the video won't upload on YouTube. We have, oh, I've written this around the wrong way around, haven't I? We've ma minus 3ma is minus 2ma. We've 3mb plus mb is plus 4mb. M's cancel, and we're left with 4b minus 2a equals 2g. And we'll call that equation B. Now we have two equations with just a and b in them, so we're going to solve them simultaneously. So I'll write them on the side here. So our first one was 9a minus 2b equals g. 9a minus 2b equals g. And our second one was, our second one was 4b minus 2a equals 2g. So that's plus 4b minus 2a equals 2g. And we need to solve these simultaneously. So it looks like we're going to have fractions in our answers. So I'll multiply the first equation by 2, and we get, sorry, that's really messy, 18a minus 4b equals 2g. And our next equation is going to be minus 2a plus 4b equals 2g. Those equations add together. The b's cancel, and we're left with 16a equals 4g. So therefore a equals 4g over 16, which equals 2g over 8, which equals 1g over 4. So a equals, let's go in here, a equals g over 4, and a is measured in meters per second squared. So that's your answer for A. Because I'm running a bit over time on the video, I'm going to ask you to solve B, but you should get an answer of B equals 5g over 8. And that was the question, to find those two values.